The acceleration of an object. Acceleration is defined as the following. Acceleration is the rate of change of velocity. Now, when we talk about the rate of change of a quantity, we mean the following. The rate of change of a quantity is how much it changes during a given time interval. So let's start the little truck moving to see how much its velocity changes over a given time of 1 second. Now you can see that the fire truck has changed its velocity. It started off with 5 meters per second and then it became 12 meters per second, and this happened over a time interval of 1 second. Now we say the velocity is increased by 7 meters per second in 1 second, and there's a special way to write down that acceleration. The acceleration is defined as 7 meters per second every second, which really tells us that in 1 second the velocity of the truck changed by 7 meters per second. Now we can write down a word equation for acceleration. Acceleration is defined as the change in velocity over the change in time. Now we also can write down a symbol equation for that using the following symbols. We can say acceleration is equal to the change in velocity, and we'll call the change in velocity the final velocity v, take away the initial velocity u, and we divide that by the time it took for the change to happen. So in the case of the little fire truck here, we would say that u is the initial velocity, 5 meters per second, v is the final velocity, 12 meters per second, and the change took place in a time equal to 1 second. So we put that into an equation, we'd get the size of the acceleration. Final velocity is 12, and I always like to put down the units of the velocity, 12 meters per second, take away 5 meters per second, put a bracket around that to show it's one calculation, and we're dividing this time by just 1 second. So the acceleration from our definition of that little truck is going to be 7 meters per second every second. Now we read it as 7 meters per second every second. That translates as every second that truck is going to increase its velocity by 7 meters per second. But that looks a rather ugly kind of unit, so we refine the unit in the following ways. We can write it as 7 meters per second with a wee 2 there. It still translates as the same. It's pronounced 7 meters per second every second. And also we can write it in the other way, 7 ms minus 2. And that would be translated the same way, 7 meters per second every second. So each of these units would be the units for acceleration, but they're translated as the same way. That little truck is going to increase its velocity by 7 meters per second every second. Let's measure the acceleration from the speedometer of a car. The speedometer is going to tell us the speed at an instant. As you can see, the car is sitting at 0 kilometers per hour at the moment. We're going to put the boot down on the accelerator and accelerate the car over a given period of time and then work out its acceleration. And this is how the performance of cars are actually measured. We see how quickly the car can reach a certain speed in a certain given time. Now let's start things off. Let's accelerate the car. You can see we're accelerating all the way up, and we'll stop it here. And in 4 seconds we have gone from 0 kilometers per hour to 160 kilometers per hour. So that's a very powerful car. Now to calculate acceleration for that, we use our same equation. We say acceleration is equal to the change in the velocity divided by the change in time. So we have got v minus u all divided by t. Now our final velocity v we know is going to be equal to 160, and our units for the velocity here is going to be kilometers per hour. Our initial velocity was 0 kilometers per hour, and the time it took for that to take place was over just 4 seconds. So we're talking about a high range car here. but we've got enough data to calculate the acceleration of that car. So acceleration is going to be equal to the final velocity, 160, and I always put in the units, kilometers per hour, take away 0 kilometers per hour, and we're dividing that by 4 seconds. So our acceleration is going to be equal to 160 kilometers per hour divided by 4 seconds, which is going to be 40 kilometers per hour per second. That's going to be our acceleration. Now let's try and understand what that means. According to our calculations, that means that car is going to increase its velocity by 40 kilometers per hour every second. So every second in the clock, the velocity is going to increase by 40 kilometers per hour. Let's try it out and see if we can catch that on the dial. Okay, we'll accelerate and count the seconds. 1 second, 40, 2 seconds, 3 seconds and 4 seconds. You can see that every second the velocity is going to increase by 40 kilometers per hour. And that's really the definition of acceleration. Note the units are kilometers per hour, so it's 40 kilometers per hour, and you get that added little extra bit every second. So acceleration tells us how much our velocity is going to increase or decrease in a given time, in this case per unit second. Acceleration 40 kilometers per hour per second means that the car is going to increase its velocity by 40 kilometers per hour every second. Let's work out the acceleration of a trolley in the lab as it goes down a ramp. Now that's the way we set up the experiment. We can see that the trolley has got a card on it. The card has a known length, and when it passes through the light gate, the small computer is going to calculate the velocity at that particular point. When it goes down the ramp, it's going to strike the next light gate's beam and cut that off, and that will measure the velocity at that particular point in the ramp. The clock, which is attached to both light gates, is automatically started when the trolley passes through the first light gate and ends when it goes through the second light gate. So we have a way of measuring the time between those two velocities. So we can work out the acceleration from that practical setup. We know the acceleration is equal to the change in the velocity of the change in time. So in equation mode, we can write down acceleration equals v take away u all divided by t. And we know that v is going to be the velocity measured from this light gate here. We know u, the initial velocity, is going to be measured from that light gate up there. And we know time t is going to be measured from the clock, which is connected to both light gates, which gives us the time between the velocities that we've measured. So let's set the little trolley on its motion, and there it goes. And you can see our data is as follows. The initial velocity is 5.3 centimeters per second. Our final velocity is 8.7 centimeters per second. So we can put these into an equation, and we can do the following calculation. Acceleration is going to equal to the final velocity, 8.7, and remember the units are centimeters per second. Take away the initial velocity, 5.3 centimeters per second. Put a little bracket around that to show we're all there. Divided by the time of 1.9 seconds. Acceleration is going to equal to 8.7 centimeters per second, take away 5.3 centimeters per second, which is going to give us 3.4 centimeters per second of a change in the velocity, divided by 1.9 seconds, and therefore we do that calculation, we get the acceleration of that little trolley as 1.8, and we put down centimeters per second per second.